started to present the 9 fields of action for our new space strategy from Germany, which will be released quite soon, actually. We think in a couple of weeks we will have this new strategy also public. So it's kind of a sneak preview today, I could say, maybe to mention that as well. So for the European and international cooperation, it's the first field of action. As I said, international cooperation is decisive, but also the independent access to space. And that maybe is to let you know, is a very intensive debate right now in Europe, because we are waiting for our new launcher, Ariane 6. But from the German side, we think also it's necessary to strive for more competition in the launcher sector in Europe, within Europe. And we have also some new private companies in Europe that are starting to build their own micro-launcher rockets, and we see a new market coming up for them. So that is something that we state also in the strategy, that is important for us to have more competition in the launcher market in Europe. Then the second priority, of course, the whole questions around new space, commercialization, to ensure that German space companies are well positioned to compete international. We want to really provide them the best possible framework, and to really strive for a strong ecosystem of private firms, startups in space. And that is particularly a field of action to establish something like a space innovation hub that is easy to access for startups. So it's easy for them to get contracts also for government, or between or with OEMs or other companies, to make these things easier, also to act more from the public side as an anchor customer. These are all things that we think are important to really push also for a strong new space market in Germany, but also in Europe. And this is linked also to some other activities we have in Germany quite strong right now, with our startup strategy, which we established, where we also try to get more venture capital to Europe. And we invest quite a lot of public money to generate also more private money for venture capital in Europe, so that we really get an ecosystem for new space startups to really develop very well in Germany and Europe. The third priority is everything around the questions of climate crisis and, of course, fighting it. And we think it's important that we state in the strategy the relevance of space for fighting the climate crisis, because in the society, not everyone is aware of how important space is for that field. And as a more concrete field of action, we really want to get even better to bring all data around climate together, make it more easy to access, and also more easy to really develop concrete applications based on these kind of data. Also maybe by private companies, but also, of course, having here an awareness for all the ministries, for example, for the whole public sector, what kind of services they could get to really have applications in agriculture, in forest management, things like that, that are important for the climate. And also we want to have a priority on the questions of CO2 or methane emissions, to have here a better monitoring to really enable us to have the data that is needed to see how the emissions develop, and eventually, hopefully on a daily basis, or maybe even on a 24/7 basis, that would be the best result to be able to manage all the things around climate. The first priority, digitization, data, and downstream. I think that is close to what I said about climate data just now, that we want to get better in really bringing the data to the people who use it. We want to establish even better cloud services around satellite data. And of course, with the European Copernicus program, we have like a huge source of data, but it's really important that we make them as easy accessible as possible. And that is important for us in the action field, digitalization, data, and downstream. Then, of course, 5, security, strategic capabilities, and global stability. As I said, the link also to the question of Zeitenwende. For us, it is really important to strengthen all activities about space situational awareness, We have cooperations also between the military and the civil side in Germany that we want to make stronger, so that we really have the different aspects of safety and security in our fields of action. And we state in the strategy that space infrastructure is becoming part of our critical infrastructure, and that it really needs, therefore, a strong protection, just as other critical infrastructures as well. And I think that is also important to realize that space is so relevant, and not only relevant, but critical to so many services we have in our daily lives, we have for our companies, we have for our security, that this is really a security issue. The sixth field of action is sustainable use of space. Here, it's of course important to preserve space as a global common good for future generations as a task for the international community as well. That is why I'm happy we were able to talk about this yesterday a little bit when we were signing the Artemis Accords, because of course there's lots of need for really joint international binding rules for who can use the orbit and how, and about also the necessity to bring satellites not only into the orbit, but also out of it in a safe way. And there we want to really be engaged as well as in a European level, but also in an international level with the United Nations, and think that the United States, of course, are an important partner in that. And I'm looking forward to have these conversations about that also in the Artemis group, but also in the United Nations framework. And Germany is also now engaged to have its own space law. We don't have a space law so far, but we see it necessary to have one also from international rules. Indeed, there is an obligation, and that's why we now start the process to work on a national space law, of course, also for sustainability reasons, but also for monitoring reasons, that we know what is there in space from the German side. And that will be a process that we are starting now after we have the strategy. Then, of course, space research. I think here I would like to mention also the question about post-ISS. For us, it's important that there will still be possibilities to have research in the lower Earth orbit. That is why we want to have now a process in identifying what kind of access we need to the lower Earth orbit for research, and how we can get to a good solution after the ISS. I think everyone here knows all the question also about private companies in that field that are now coming up, and how we see the situation for Germany in that. The eighth point, international space exploration. Of course, Artemis is a major program that we are contributing. We are very proud about the European service module that we are providing for the Artemis missions. And that's flew already with Artemis 1 last year around the moon. And so this is something that we really want to stay engaged, because we think the exploration part is an important one, and we really want to keep a strong relationship with the US program Artemis as a strong partner for that. And as a last point for the strategy is a space dialogue and talent acquisition, because we see it's really important to have the society seeing how relevant space is for their daily life, for very important challenges the society is facing. And that is why we want to invest more in like all outreach activities. We want to open our places where space happens in Germany, make them open to the public, and see there also an important point to really bring new people, new talents to the field of space, especially more women. We want to really have it as an attractive field for people to come to work in the field of space. So this was an overview about our new strategy. And now I would like to dive a little bit deeper into some concrete examples of the US-American-German cooperation. First, within the framework of ESA, where Germany is the strongest contributor for the ESA budget. So that is a very important field of action for us. And then I also want to mention some of the bilateral cooperations we have in the US context. So the first one is the one I mentioned already with Artemis. It is the European Service Module, and it's here I want really to highlight is because it's the ESM is crucial for the Artemis missions with Orion. It's like the one you can't do it without. If you want to have astronauts there, they need the service module. And it's manufactured in Bremen at Airbus, including contributions from other German suppliers and European industrial partners. And Germany finances and produces a share of over 50% of the ESM. I think that is an important signal how relevant we see really as a partnership with the US here in this field. And I can say also in Germany, we have hard times when it comes to budgets. And so for us, it was really a big step to manage to get this high budget for the ESM and to stay such a strong partner for Artemis. And there's also the next project is linked to the Artemis program. It's a European large logistic lander called Argonaut. It's right now ESA is planning the Argonaut project, and Germany plans to participate in the development of the Argonaut lunar lander, which will be up to 1.8 tons of material to the lunar surface will be possible to bring this with this kind of logistic lander. And just here are some examples and possible payloads could be scientific missions and as well as energy supply. So this will be like the second big, huge contribution around the moon exploration that would come from ESA with a strong German participation. And then, of course, the project that all of you know, the International Space Station. But I really want to emphasize here also that Germany provides the largest European contribution to the operation and utilization of the ISS. And there are more than 500 experiments on the ISS that originate from the ESA utilization programs, and German scientists were involved in more than 200 of these European experiments. And some of the two people who were there and conducting these experiments are here today and will also say a few words after me. And the Columbus Control Center at DLR Oberpfaffenhofen manages the operation of the European ISS module Columbus in close cooperation with the ISSQ and NASA's control centers. So there's also a strong really place in Germany where things around ISS are controlled. So that is all are the three projects that I wanted to present for the collaboration within ESA. And now I would like to mention some of the bilateral cooperations that we have directly between Germany and the US. And one very prominent project, I think, is GRACE. The GRACE mission, where we have now GRACE C, GRACE Continuity. And GRACE, as most of you might know, is a very important mission to monitor water around the globe. And I think here with the GRACE mission, it shows how important it is to have the continuity in the collaboration of the two nations, because that is also what scientific research needs. It's really the data over time, and that is why we think it's really a success that we are now able to do the third mission for GRACE. That also was not easy to get through all the budget negotiations, I can say. But as it is a very important project for us, and as we see really this continuity is so important, it was for us very good that we are able now to have the third mission for GRACE after the first one, then GRACE follow on, which is in orbit right now, and then we will see GRACE C, which is in preparation right now. And it's a joint program on the German side from the Ministry of Economic Affairs and of Research. And there you can also see that we have strong collaborations between the different ministries for space in Germany. And then I would like to mention the NB Hub in Germany. It's with the NB Hub, the DLR Institute of Aerospace Medicine has a highly specialized laboratory for studying the effects of microgravity on the human body and the influence that nutrition and countermeasures have on these effects. So it's an important hub based in Cologne in Germany, where really are very specific possibilities for experiments around that. And for this reason, DLA has already conducted extensive bed rest studies, also with NASA. And I think that is really a very special place to conduct these kind of studies there. And we are happy that we can collaborate with NASA there. And then I would like to mention one of the experiments that was on Artemis 1, the MARA experiment, and we had it yesterday on the Artemis Accord signature ceremony. There you could see the two female phantoms called Helga and Zoa, who recorded the radiation exposure to the human body during the flight. So we were very happy to have just on the first flight of Artemis such an important experiment from the DLR side, and the analysis of the data is already well advanced at the DLR. Scientists will present some preliminary results to NASA in Washington at the end of September, and I were asking one of them yesterday, but he didn't want to get any preview on that, so that will be very exciting to get to know the results then very soon. And then, of course, the bilateral research on the ISS would be the last point I would like to mention, because, of course, all the experiments that are conducted on the ISS are very important to us, and there are specific experiments that are also really a bilateral collaboration. Some of them are mentioned here. It's the Big Hell project, Bose-Einstein condensate and cold atom lab, and also the project DESIS, a hyperspectral instrument developed and built by DLR and now operated on the ISS by industry partner. Yeah, so that is an overview of all our activities. And let me end by stating that we from the German side really see space policies and space activities even more relevant than before. And we have, that is why we have now the new strategy coming up from the German side. And we really see it important on the different sectors, as you have seen, for security, for climate, for international collaborations, for geopolitical questions. In all of these fields, critical infrastructure, space is really of new relevance in these times, and that is why we are seeking also the close exchange with our partners, and that is part of why we are here today. And I'm happy to take questions and to be part of the discussion afterwards. But now I would like first to hand over to our two astronauts and give them the opportunity to say a few words about their work on the ISS, and then they will also be happy to take some questions afterwards. Thank you so much.
Thank you, Anna. Thanks for the quick introduction. Thank you, Scott, for the invite. It's actually quite amazing to see a little bit of the background on how ISS and the collaboration came to existence. To me, that's very interesting. Matthias and I, we're both two astronauts from Germany. We spent about 1.5 years in space between us on the ISS, of course, which is the main destination for now. We heard about new, even more interesting destinations, of course, right now. So thanks to all of you working on this. If you like, we can do a little question and answer. I'm not sure how many people are online. I don't see that here. Do we have indications? And you can probably collect questions from them, right? Yeah. So I'll just hand over to Matthias here in a second. He can introduce himself. Maybe just two more words for myself. I'm a geophysicist. I came in like all of us, through a different profession. Astronaut is something you do on your sort of second line of education, which is nice. Sometimes a big choice. So you already an established scientist like Matthias. He's a materials scientist. I'm a geophysicist, and then we see this job announcement at ESA, and we go for it, not thinking that anyone would ever take us. At least that's what my assumption was. I didn't think I would be an astronaut, and then I was surprised. Okay, ESA said you can come. We really want you to fly to the ISS for us. So this is how we got in. And now it's interesting that several of us come back to their original profession in a way, a little bit working with lunar program. Of course, there's lots of geology and geosciences, also material sciences on the ISS, a very big field. So in a way, some things that none of us would have ever predicted is that we enter this program and then all of a sudden work in our original fields again. So I'll just hand over the microphone to Matthias, and then I think we can collect a few questions if you like.
Yeah, good morning also from my side. Yes, Alex already mentioned, we spent quite some time on the International Space Station, and there we do lots of experiments. Roughly, it's between 100 and 150 experiments per increment that we participate in. And since we're here in the US today and we heard about our space policy, to give you only a few examples of what we did on the ISS that falls into this area, it's like Alex performed an experiment that I also performed later on. We both mixed concrete in space. He did it for a US research institute. I did it for the German DLR Institute. In the end, mixing concrete in space has the very important background that if we can understand this material, which is so widely used and is responsible for 7% of the CO2 emissions, the climate active gas, then we could probably learn so much and try to optimize it. And during my experiments, for example, it was found that some of the mixtures I produced in space are 30% harder. So if you can take this and say, like, we need 30% less concrete to achieve the same, then you would immediately save 30% of CO2, which is more or less equivalent to what the entire aerospace industry releases as CO2. So you see, like, one small experiment on the ISS can have such a tremendous impact. And we definitely need to continue doing this research up there in space. ISS is not primarily focused at climate change, but definitely we also can contribute there. Another aspect that was mentioned is international security and safety. While I was up there, only 4 days I was in space, actually, we were called out during the night saying, like, oh, you need to go into shelter because a satellite broke apart. In the end, it was not just breaking apart by itself, but because the Russians shot down a satellite. And this immediately tells us as well, we need rules, we need regulations, we need the entire world community taking care of the new frontier of space. We need to come to international agreements that such tests, if they're called tests, are illegal. And I'm happy to see that already Germany and the US have signed a related paper to say that they will not conduct such tests in space. So these were just two small examples touching our field of area, but also touching the broad background here. And now we're both happy to take questions.
Actually, I have one more thing that you just inspired me to think about, and also what Scott mentioned before on how sometimes big projects hinge on potentially very small but significant moments. And I think this is really your field of expertise here, and that's why I think it's to me very inspiring to meet you, who are really thinking of this from the bottom up and how to make those corporations work. And the space station, as you know, has been called like superlatives of any kind, right? They say it's the most complex machine that humanity has ever built, the most valuable machine, arguably the fastest machine that well, some of the fastest machines that humanity has ever built. But thinking of all this, I would actually call it the most improbable machine that humanity has ever built. Now imagine you were a decision maker right now, and somebody of your staff proposed you a project. They said, okay, we're just going to build a machine on orbit, 28,000 kilometers an hour, 20,000 miles. And we're just going to build it on 4 different continents with pieces that need to fit a hundredth of an inch together. And we're never going to plug it together on Earth because we don't have time for that. We're just going to plug it up there in space. And we cannot go to Home Depot for a packet of screws if we forgot them. And yeah, we're just going to do it. So what would be your answer? Like, what would be your assessment? Is this doable or not? And so obviously we now know the answer because ISS flies. It's this amazing machine. But I think we also need to try and learn from this. How do we do that in the future? How do we prevent people to say, no, not doable, we cannot do it. Let's just use that money for something else. How do we get those projects on their way in the future? And that is something I think it's worth thinking out thoroughly, because what I see in Europe and Germany, there's a lot of big projects that tend to get negative press sometimes because they have time overruns, cost overruns, and then that negative press sometimes can take over and take some of that achievement away. So how do we do that? How did they do it for ISS? I mean, it's still, to me, amazing, and I think it has to do with people with visions. Some of them potentially in this room who got those projects on their way, fighting against just doubts. I don't know how they did it. Actually, that would be my question, to you, Scott, if you have a moment at some stage to share how those challenges have been met and how you get a space station on the way. And part of it, I guess, is also what you described as the international cooperation. I've been working on and off for my mission training at NASA since almost 1.5 decades, and I've seen the projects in the past that were supposed to go to the moon or out there in outer space that were canceled. Now, seeing the Artemis program, to me, is a totally different experience. I could feel it on the aisles walking around at NASA and other space agencies. There's a totally different spirit out there that people are really going there now. People know, you can see it when you look in their eyes when you talk about it. They know we're going now. It's totally different than the programs before that were there and that were eventually canceled. That's why I'm actually quite excited to see this, because you can feel this one is going to go. And I think this is the experience, or the achievement of this international cooperation. Like Scott, you mentioned it before. It's harder to cancel a program that has international partners tied in, because you would disappoint your international friends, like if you pulled out. And I think this is a deliberate tool that people use, of course, to get projects through that they don't want to have canceled, because if you set it up in this way, you can weather through a few more storms. So I think that's part of that that success that we had in ISS and that we see now for Artemis. So maybe if we have some time for those questions, but maybe Scott, if you have a minute later to share with us how that, in your opinion, came about, that the ISS actually came to existence against all those odds later. That would be, for me, very, very interesting to hear.
I can see from a couple of my students here that they're going like, that's like about 3 lectures,
Yeah.
they're thinking about. And on the point of international cooperation, making it harder to cancel programs, that is a trade secret. Please do not tell the Ministry of Finance. They hate that. But let's shift to, we have some questions from people here on the audience or online. And sorry for us coming up and bothering you on the viewing screen, but we were getting feedback from the online audience that they wanted to see more of you, so we put a larger screen up. And one of the first questions, here for all the involvement in the ISS and so forth, where are the German women astronauts? And when might be there some opportunity for them?
Well, that's a really tough one right now for, of course, for us to answer, because we happen to be men, we happen to be from Germany. I think to give you the honest answer, you'd have to look at how astronauts are selected, how that worked in the past, and how ESA works also. So when in the past selections, ESA has called out a huge selection round where people have applied. Like in our selection round, it was about 10,000 people from all over Europe. Now it's about, so the latest round was about 23,000 people all over Europe. And one of the challenges that we had in the last selections was that we only could mobilize about 1/6 of the applicants to be women. We thought that was quite unfortunate because, I mean, in our community, it's clear that astronauts, women astronauts and men astronauts are just as well working out there. There's no difference. I've been flying into space. Matthias has been flying into space with lots of mixed crews. And so for us, that's not even something to think about, but we realized that we weren't able to motivate enough women to apply to get that balance right. So in the selection before, it was 1/6, about 1/6 women that we could motivate. Now in the latest one, we doubled that number, which is already a big success, but we're still not there at 50% where we would like to see those numbers. And then for the final call, and I was only there as a participant, so I cannot really speak for the decision makers at the time, but it did not play a big role on a certain gender perspective, just certain gender or experience, background, a number with respect to a certain country. So the European Astronaut Corps is European. It's truly European. We call ourselves European with a German accent. So Matthias and I, we're German astronauts, but actually also our proper job description is European astronaut. And so we see the European Astronaut Corps as a total. So we don't exactly look at who's there with which background from which country. And so that was the actual reason of why in the European Corps, where we had the four astronauts from Germany, Thomas Reiter and Hans Schlegel and Matthias and myself, that there was not a woman there. And so, of course, this is something in general that we would like to change. And I see Anna Christmann, her perspective from the German government also certainly has an interesting perspective on that. And I'm pretty sure she's helping that cause as well.
No, thank you so much for giving this background. And yeah, I just wanted to underline that, okay, I have to move into the picture. To underline, yeah, that for us is an important topic. We are proud of our current astronauts, of course, but like for the future, it's important for us to really get more diverse also in the crew. And that is why we are happy that like now in the last round of selection from ESA, we have now 2 women coming up from Germany who are like for the next generation of astronauts. And so we are getting better and looking for the future. And as I said earlier, for us, it's really important to attract more women for space. And definitely it's important also to have role models in the astronautic crew as well. But as Alex said, of course, for us also the whole ESA core is important, and there are now also more women than before. That is something that we support from the German side. And also we have already one very active female astronaut, Samantha Cristoforetti, that is already also a great role model, just as you are. And so I think it's an important point, and we are really trying to support that from the German side. And maybe I also can go to the next question that's on screen. Our participation in Artemis, according linked to our signature of the Artemis Accords. And maybe I can come back to what I said earlier. our contribution to Artemis from Germany as like a very strong partner in the activities with ESA. And as I said, it's not easy for us to have this really large part, for example, on the European service module, because that is like the most costly partner from ESA, and in more or less it's like a significant part of the whole exploration activities we are supporting. So for us, this is already a very strong contribution from Germany, because we are the largest partner in that. And that, like for the future, that is also true for the Argonaut project, where we are really engaged from the German side. I mean, that is something that is still to be developed, but we see this also as a very important part from Europe to contribute to the whole Artemis missions. So if you want to say so, maybe we had a flipped sequence of signing Artemis Accords and being engaged in projects, because I think, yeah, what we are doing in Germany for the ESA project is already a lot. But of course, we are now in a close relation and in deep discussions also with the US side. That is why we are also here and discussing how the strong partnership with Artemis can go even further.
So yeah, for the Artemis architecture, I mean, a lot of the elements are already well defined, but looking ahead, once we arrive on the surface, I think there we can also look into European and especially German expertise in how to make the best use of resources that we find. I think we have very strong technology in Germany, very good people, very good scientists already working in these aspects. And so I dare to forecast that we will be a leader in experiments and exploitation that we do on the surface.
Actually, I would add one more thing that I think is important to the diversity question, which I do think is very, very important. So we saw that on the ISS so far, that diverse crews, and I actually saw that also in Antarctic expeditions. I was taking part in 5 Antarctic expeditions as part of my previous and my current job. And we do see that diverse crews in every respect are way more powerful, way more performant than like more singular groups. And so we're really trying to get this in the right way in every respect. This is not just gender balance, but lots of things like experience, age. And there's, because of that, also a project that we're running now at the European Space Agency, which we call the FLY study, which is to study, for now, it's a feasibility study, the potential to fly an astronaut with a certain physical limitation to the ISS or on board a spacecraft. The reason for that, and that is important in my opinion, is not that we want to just show how like inclusive we are, or that we think, oh, this needs to be done because it needs to be done, but actually, in addition to the diversity thought, is that we actually think we can increase the performance of a crew by bringing in people that have very unique experiences made in their life, which translate in their ability to solve certain problems. And I think personally, I've worked with people with physical limitations in the past when I was working at the Red Cross. I actually think this is a huge asset to have somebody on board who knows all his life how to solve problems and how to encounter problems, because they're encountering many more problems than people without those physical limitations do. So this is just one more thing that we're trying to do to actually get space crews more performant and more diverse.
Great, then maybe we continue with the next questions. So it's about the capability for human spaceflight in Europe. And there, from the German perspective, for us, the whole launcher question is more like in 2 steps. And what we see now is very relevant. Is the first step to bring more competition to the whole launcher sector in Europe, because what we see, and we are happy about that, is that we have really more and more private companies that start really also just like it's happened in US already several years ago, that we see more and more of these new companies. And we have around 3 in Germany. that are working on like small launches right now, but of course they are planning to get larger maybe over time. So that would be the first step for us from the German side to get a more dynamic launcher sector in Europe. And then the next step could be to see if how this develops, and then to see whether there might come an opportunity for that to also develop them further to human space flight capabilities for Europe. But for us, from the German perspective, it would be important to have the first step now, and that is like really a change for the European system so far, because now we like have only Ariane and Vega as the two fixed possibilities. And when after the first step of more competition, we like might see whether this could be an opportunity to also go into human spaceflight from Europe, but like as a second possible step.
I want to take advantage of some students in the audience. So any of them want to, oh, sorry. Oh, you had a question. Okay, the professor goes first. Okay.
Yeah, working. Just the I want to go back to your few comments on space law, and that is it straddles all of the 9 areas that we were talking about. That isn't a specific one, but I remember about 25 years ago, Germany had a fairly major program to look at space law. And it never did result. It resulted in a lot of studies and some good reports. It was headed by the Cologne Institute. But the government never passed a comprehensive space law. Instead, with TerraSAR X, when that was launched, the remote sensing satellite, they did pass some very specific rules, particularly with the public-private aspects of handling remote sensing data. So the question really is, do you think that enough has changed in the politics and in the space area that the government will act differently this time? Or when you have specific missions, that you may just be take the earlier model and write laws specific to those missions or those problems rather than the comprehensive space law this time?
So the short answer is yes. I think it has changed a lot, and that is why we included it in the strategy now. And I think that is an important step, because it's a strategy for the whole government. So of course we had intensive discussions with all the ministries, and now it's a joint decision that we will have a space law for Germany. And of course, there are questions coming with that you were referring to, and which were the reason why we don't have one yet. But I think we have now like a guideline that will make it possible to have a law that addresses, of course, safety questions. I mean, it has to be possible to reach someone when a satellite goes somewhere you don't want to have them. And just now we don't have any rule for that. And we have some incidences. Walter Pelzer could tell more about these on the weekend, where university is not able to be reached, and the satellite of the university is going somewhere. And you're questioning, oh, what is he doing? So that's our reasons why we really need this law. But on the other hand, of course, what is also important for us is that we are attractive for new space startups, for companies, of course, to be in Germany and doing space. So we will also look at that is will be still attractive to really develop space technology in Germany and to have space missions from Germany. So these are the two ends that we want to bring together.
And was there questions from the students? Yeah, just press the on button. Goes red. Yeah.
Does that work?
Live.
Okay, hi, thanks. Besides what has already been mentioned, are there any pieces of space law or like international agreements that you guys would like to see in the future? Yeah, just like any international agreements that you would want the international community to agree on.
Yeah, we were just discussing like to what kind of questions you might be referring. Of course, as I said, we are really engaged in the international level for common rules against space debris, these kind of things. That is for us a major topic, which is of course very relevant also for the experiments and the science that is happening, as we have heard the story by Matthias, to make it safe to be on ISS and other things. So that is one example, of course, which is very relevant for us. I don't know if you were referring to more topics, but yeah, it's a relevant topic for us. Yeah, I will just like you could add all the issues around that, like space traffic management, of course, where we have rules who has to go out of the way, and to going to meet each other in orbit. So these are also things, and we having strong activities on that in Europe, and we are like engaged in these European processes where the European Union really wants to move forward very strongly, and we think it's also important to address that also on the international level. So everything around space debris, space traffic management, all these kind of questions are very important for us on the international level.
Okay, and I might just take post privilege for the last question. Oh, there was one more. Well,
I'll let you the privilege of the last question and I'll ask one more before. Thank you very much, Dr. Hirschman, for your intervention, and also to both German astronauts. I would like to know if you could explain a little bit more how the new space strategy was defined, what is the organization within the German government and the link with the different agencies, and how you prepare this and maybe the future space law. Thank you.
Yeah, thank you. I skipped that a little bit in the beginning because I wanted to save a little bit of time. But for us, I am the space coordinator for the whole government, but I'm located on the Ministry of Economic Affairs and Climate Action. So that is so I have a little bit a stronger link, I'd say, to the specific ministry, but my role is for the whole government. And that is why also our ministry has like the leading role for space in the government in Germany. But for the space strategy, of course, it was a process of the whole government. So we work closely together with all the ministries, especially we have some of them that also have a major role in space beside us, that are, for example, the Ministry of Transportation, because they are in charge of the European programs, Copernicus and Galileo. And then, of course, the Ministry of Defense, which has some space programs and so on. So we have some of them that are more involved and others a little less, but it was a process with the whole government. That is why it always takes a little time to make a new strategy. But that was important for us also because we also were able to raise the awareness of all other ministries for the for space in general, because some of them are already very active, but others might be even more active, and that would be important also for us, and is actually part of the strategy, that we want to see also the Ministry of Agriculture, of ecological questions, all these ministries also be more involved, and to get them to use more the potentials that are out there in using satellite data, and maybe also buying commercial services to get the things to know that they need. So that was a process, and in addition to that, it was very important for us to get input from the whole community in the beginning. So we had several workshops with industry, with researchers, with several people. Matthias was part of one of the workshops where we got input at the beginning when we started to work on the strategy. So that was also very important for us to have this participation in the process. And now we are almost at the final end of the process, and I'm very happy about that. I hope that could answer your question.
So I know you have meetings coming up at back. My French student.
I have a question. But if you allow so, or we can, and okay, it's a quick question. So Artemis 2 is planned to be launched in 50 years. Another crewed mission on the moon. Kennedy did it in a decade. So what do you need currently to to be able to plan this mission? Why do we have to need 50 years? Is there more technology or new technology that you would like to develop, or why 50 years?
Yeah, well, so when Kennedy called out the space race and to put a man on the moon and bring him safely back before the end of the decade, that was an urgency. He wanted to show that the US can do faster and better than the Soviet Union. The risk that the people who flew on these missions were taking is much, much higher than what we are willing nowadays to take. We've seen there were accidents, 2 shuttle accidents. And so NASA takes it very, very seriously to provide the highest level of safety to the crews. And so it takes longer now to fly a mission, but the safety for the crew is much, much higher than during the Apollo times. And I believe that is the main reason why it takes so much longer. Also, after the Apollo missions, it was believed that the moon is a dead body that has nothing to offer, just dry sand. But thanks to satellite missions, we found out that the moon actually has water ice in the polar regions. And though there's a lot of science that we can discover on the moon, but it took a long time until we understood this. And that's why we started quite late. And flying to the moon, since it's 400,000 kilometers away compared to the 400 kilometers that ISS flies in, you need a lot more fuel, you need powerful rockets. And the business case for flying to the moon wasn't there in the beginning, and as we have for low Earth orbit. So that's why the entire infrastructure needed to be developed. And that is only possible if you have support from all the politicians, usually bipartisan, not only from one party. And it's a program that is longer than the 4 years term of one president, or maybe 2 terms, 8 years. So you need to have the scientific background, you need to have the political background, and you need to have the economy in place to support this. And so it's usually a challenge and not as easy to implement if one of these pieces are missing. Yeah, so you need a strong president with a clear vision, and then you can go.
Maybe he can be the fuel.
Okay. I just wanted to add one more thing to the first question before, because what I forgot is that we, of course, in the first phase had much help of our space agency. And I wanted to mention that this is also important for us in Germany, that we have the ministry and the space agency, like NASA. And of course, they were very much involved in providing the first draft of the strategy. I think it's important to know, if you ask about the process, that of course we work strongly together with the agency.
Okay, thank you. And excellent question, and a great answer on why it's taken so long for us to get here. Our understanding has evolved. So I know you have to be over at the State Department soon. So let me maybe ask a question that maybe leads into that, but maybe more open-ended. You mentioned earlier about the anti-satellite test moratorium ban and the support that's had. But of course, the open-ended working group in Geneva was not able to come to a consensus on even a procedural report, because Russia, vetoed that and blocked consensus in that area. So on one hand, there's been an increase of countries who are coming to sort of like-minded ideas about responsible behavior in space, certainly differences, but coming to some ideas. On the other hand, our ability to use the United Nations and the consensus-building approach that I think has been so important in space as we run into difficulties, particularly from Russia. What are your recommendations to the State Department that we ought to do next? Do we just keep trying? Do we do something different? Do we stop? Given sort of the reality of the situation you're in, we are all in. What are your thoughts on what might be some options to what we ought to try next?
Okay, I think if I would have the answers, that would be very great. But as you said, it's just a very difficult situation. For Germany, I can say for us, it's really important to have really the multilateral process in the United Nations still, seeing that it's difficult. but stopping that wouldn't be an option from our side. So that is important for us, that we work on that and that we really try, because it's important that like space is for the whole planet relevant. So we should always try to find solutions for the whole planet and for all the states on this planet. So that is for us a priority, and we will always try to work on that. Still, as you mentioned, it is difficult, and we see, for example, also with the Artemis process now, important steps to try to find common sense, common values, a common approach to also these missions that might add on that, but we would never see it as a replacement for the multilateral relations.
Might add to that relative to Dr. Hertzfeld's question about space law. I think one of the things that we're thinking about here, or colleagues are thinking about, is that we take these non-binding guidelines, like the long-term sustainability guidelines, we work on implementation, and we see what we can do in national law and regulation. So barring a comprehensive approach, what can be done at a national level to improve? So, we're working on various ways and regulations, hence our interest in your progress on there, because so while we still are open to multilateral engagement, we want the multilateral engagement, that doesn't mean we can do nothing in the near term. In the near term, there are things that we can still do at a national level, certainly in coordination among like-minded countries.
Yeah, no, that's very true. Thank you for that. And maybe let me add that we have on the European level also discussions going on a European space law, like also with the idea seeing what has to be done on the national level, what can we do on a European level, and then like what can we do with partners and what they might implement in their national law, and then always trying to also get to the next level. I think if we do this in parallel, that is a process that is also something that we really support.
Thank you very much. And I guess we'll maybe let you go to your next meetings, and really thank you very, very, very much for making the time, for coming and spending time with us, and coming time with our people online watching this. And we will be making sure I'll make it a reading assignment for my classes. But sorry. No, but thank you very much.
Thank you. Yeah, just thank you for having us. We are really happy to be here and have to all these conversations are very helpful for us as well, and happy to be here.